Hello and welcome to an information video of sorts. Since there have been a few questions here and there about what I'm using to record my videos, and well, since I have spent quite a bit of time trying to figure out the best way to record videos myself, I will give the answer to this question right here in this video. So first of all, note that I'm using Linux for recording the massive majority of my videos. Right now, what you're seeing is a terminal screen with some of the details of that. Also, since I'm using KDE, here's another thing that shows that this is indeed Linux. It's KDE 484. Yeah, so anyway, there are several reasons for me using Linux for this. First of all, Linux is my primary operating system, and this is where I spend most of my time on. So basically, if I had to boot to Windows every time I wanted to record something, well, it would be very tedious. And furthermore, well, Windows itself is severely limited, hard to configure, lacks proper software, and has a lot of unneeded bloat. And of course, it's proprietary and closed source, as well as lacking security and being often unstable for me for some reason. So I want to have as little to do with Windows as possible. And of course, lastly, Windows lacks certain features that I simply cannot live without now that I have switched to Linux, and it includes proper recording software. So yes, in order to tell you how exactly I'm recording everything right now, I will have to give you a bit more information, and that may take a while. Now, in order to explain the principle of how video recording on Linux works, I have prepared a few simplified graphs explaining the whole process. First of all, take a look at the legend here, so you would understand exactly what we're talking about here. Graphs are like that, and if something is given in a background that is reddish here, that means it's hardware. For example, the screen, it's hardware, the graphics card is hardware. If something is in a blue background, that means that it's a software component, for example, the game. If it's in green, that means it's a file and it's not doing a whole lot. And if the software is also in a blue border, that means that it's manually invoked and not automatically started. For example, you have to manually start the game and manually start the recording programs, but you don't have to manually start something like your graphics card drivers. So that's that. Right, so let's go to this graph. Now, this method that I've been using previously when I was recording things like Heroes Chronicles, Warlords of the Wasteland, it's slightly dated and I'm not using this anymore, but just to give you a perspective of what I have been doing earlier, and as a starting point, this still works quite well. Oh right, and one more thing I didn't mention about the legends. There is... all of these things are connected with arrows. Red arrows means that it's a video stream, which, for example, goes from the game to the screen. Green means that it's the game audio stream, goes from the game to the headphones, for example. And the blue means that it's the microphone audio stream, which goes from the microphone to somewhere. Yeah, so in this graph here, let's see what happens when we follow the video stream. So the game outputs the video, for example, into Wine, or it could be DOSBox, or if it's a native game, it could just output it directly to OpenGL. Anyway, one way or another, the thing goes to OpenGL at some point. Then OpenGL translates that to something that the graphical server, the X server on Linux, understands. Then what the X server does is it sends the data from all of the different windows and whatnot into the graphics driver for the graphics card. In my case, it's FGL-RX, or FireGL and Radeon for X. The drivers process all of the data into something that the graphics card can understand, and the graphics card itself sends the data on screen, and so that means that we can actually see what's going on in the game. Now then, what else is happening with the video stream when you are trying to record things? Well, since I'm recording everything using the tool FFmpeg, right here, what it does is it takes the video stream from the X server, and it, well, doesn't take everything, but a part that you define, and it produces a video file out of that. So that's what happens with the video stream while recording. Now with the audio stream, if we're taking the game audio, it also goes through Wine, or again DOSBox, or directly to ALSA. Then ALSA, the Advanced Linux Sound Architecture, is acting essentially like drivers for the sound card. It sends everything to the sound card, and the sound card then forwards everything to headphones, so that we can actually hear what is going on in the game. And in order to record what ALSA is sending to the headphones, you need to have some recording software to do that. And SOX, or Sound Exchange, is exactly that. It can take the stream from ALSA and output it to an audio file. The last stream that we care about is the microphone stream, because we definitely want the viewers to actually hear what I am saying right now. And so, the microphone is kind of different from the previous two streams, because both of those originated from the game, which is within the system, while microphone is an external device. So unlike the stream that goes outside into the headphones, the microphone stream goes inside the computer. It still goes through the sound card, and it still goes through ALSA. And I also used SOX to take that stream and record an audio file with that. Now, once the recording is complete, I used to have 3 video files like that. And then, basically, you have to have 1 video file in order to upload something into YouTube. You can't just ask them, hey, you have 3 files, and could you please mix it to 1? Well, no, that doesn't happen. Instead, you need to use some more software to combine all the 3 files into 1 single video file. So first of all, I used another instance of SOX in order to combine them into 1 combined audio file. In addition to that, what it's not shown in this graph, but it's something here, is that I also use SOX in order to do some special things like normalize the audio volume and to remove the noise. So that's another thing while using things like SOX is actually very useful. Then we have a combined audio file, and then we also have the video-only file. We still have 2 files, we need 1. So what we do is we use another instance of FFmpeg to combine both of them into 1 video file. And that video file can now be uploaded into YouTube. So that is what I was using in the times when I was recording Heroes Chronicles Warlords of the Wasteland. However, this type of recording still has a few issues. Mainly that is because, as you can see here, we are using 3 programs to record everything that we need. The problem with that is that if you have 3 programs that are not really talking to each other, then if one program gets desynced, then, well, it just gets more and more distinct, and there's nothing you can do about it. I thought about a better way of doing that, and I found out a pretty good way to do that. And this is the current method that I'm using to record things. The video stream is absolutely the same. It's just oriented a bit differently. Still goes from the game to Wine to OpenGL to the X server. From there it splits to GLRX, to the graphics card and to the screen, and to FFmpeg, which outputs a video-only file. There are differences in the way I am recording the audio, however. Here I also added Pulse Audio, because right now I'm using that, even though it could be just as possible to do with ALSA. Just that it's basically nicer to do it through Pulse Audio, because it brings quite a few nice features to it. But it also makes the thing a bit more complicated. But anyway, the game audio stream goes into ALSA. Then the ALSA stream, while normally it would just go to the sound card, it's intercepted by Pulse Audio. Then Pulse Audio itself sends the stream to ALSA after it's done the processing that it has done. And Pulse Audio then sends the stream to FFmpeg. Then the stream that goes to ALSA, just like before, goes to the sound card, then goes to the headphones, and we can hear what is happening. Then if we are following the microphone stream, we can see that the microphone again goes to the sound card connects to ALSA, and ALSA connects directly to Pulse Audio. Then that stream, again from Pulse Audio, goes directly to FFmpeg as a different stream. It gets then outputted to a separate audio file. Same thing with the game audio file. So essentially not a whole lot has changed. We have Pulse Audio that is central to everything, and we have FFmpeg instead of SOX doing the recording. The difference would not be normally that big. However, as you can see, since there are 3 things going into FFmpeg, 3 things going out of FFmpeg, everything is done in a single file, a single program, I mean. The program can then use different methods in order to synchronize audio and video. There is a problem here, however, and a problem that I have not found a solution to yet, which is unfortunate, that FFmpeg does not really synchronize Pulse Audio and video from the X server correctly because of different timestamps. When the video streams come in, FFmpeg gets timestamps that are relative, basically from the start of the recording. However, when it records the audio stream, what it gets is absolute values from the time that the Pulse Audio daemon was launched. And since the timestamps, of course, don't match, FFmpeg gets extremely confused and has no idea how to synchronize audio to video. So that's kind of unfortunate. And if I do still try to do something like that, I get very low frame rates. So that's that. Very unfortunate, but I think that in the future they might fix that. To have uniform timestamps everywhere, and so you will be able to synchronize audio and video on the fly. I still have to run a few tests to see if I can synchronize things after the fact, although I think it didn't work either, so I'm not sure how that works. Anyway, the other part, after we've recorded everything, is again pretty much the same. Two audio files get processed and mixed into one file by SOX, and the combined audio file and the video file are again combined into a single video file by FFmpeg, and that video file is ready to be uploaded into YouTube. So that explains that. That was the whole logic, the concept of the recording process. However, what I did not go over is what are we supposed to do in practice? How do we make everything like it's described here work? Well, I will try and explain that too. So, first of all, obviously, in order to record this, I have to have a game that you can launch and you can see. Because if you don't have it, then what are you supposed to record? In order to set up the games on Linux, you have to mess around with Wine or with DOSBox, depending on what kind of a game it is. I will not talk much about that because the setup of different games is very specific to the game itself, and you can find more information about that on the DOSBox and Wine web pages, so I won't talk much about that. I will mention though that in order to launch DOS games, I am using a DOSBox game launcher, which is quite useful for doing things like that. You just set things up one time and then click run profile and you get the game. And similarly to that, I am using a special program to handle everything that is related to Wine, and that is Q4Wine. Like that. Again, you double click an icon and it launches the game automatically for you, provided that you have set things up correctly beforehand. That's all it is I want to say about the game setup. In order to record, however, you also have to set up your recording software. And the first thing you have to do is to install that software. To do that on OpenSUSE, it is required to add one repository into the list of repositories and then installing the thing. I will also quickly show you how that is done. So first of all, you go into Yast if you want to have a graphical interface. It's not required, you can go through the command line, though I generally prefer to have a graphical way of doing things in this case. So here we have all of the repositories that I have added. The repository that you need in this case is Pacman Essentials. There are different mirrors for that, and essentially that's a repository that has software that deals with multimedia. In order to add it, you just click Add, you get the name, paste the URL, you can find it on the Pacman webpage, you can search about that too, and then you add it to the list of known software sources. It sees what software is available there, and then in order to install it, all you need to do is open your package manager. You can again either do that using the graphical tools or the command line. I can also show you while it's loading how it's done through the command line. In order to install the tools that we will need, which is FFmpeg and SOX, with the command line, all you need to do is write you need elevated privileges, so sudo zyper install FFmpeg SOX. Then it asks you for a password, so that it's really you and not some kind of a virus trying to install things for you. Once you have verified that, it asks you if you do really want to proceed. Then when you proceed, it downloads the required program as well as every single dependency that it needs, and it installs it automatically. You don't need to download anything from anywhere manually. You don't need to install things by your own. Everything is done automatically by the package manager. And if you want to do things graphically, you can also do it like this. For example, search for socks, put a check mark on it, then search for FFmpeg, put a check mark on it. It's not selected right now because I'm using a version that is compiled manually, and it's because there is one bug in FFmpeg that dramatically lowers the performance of the recording when using Pulse Audio for some reason. It's not been fixed yet, but I hope it will be fixed sometime in the future. So anyway, if you click things, then look at what happens here. You can see that it's ready for installation. You click continue, and it installs things automatically without any further inquiries. You need to press next. Yeah, so anyway, that way you get things installed, and you can also make sure that everything is working fine by executing socks minus actually, wait a minute. First FFmpeg minus version, and then socks minus version. And here you can see that we have FFmpeg working nicely. Peg version something, that's the Git name for it because I compiled manually. Normally you would probably see something like 1.18 or something. A lot of information about how it was compiled, and here you can also see that we have socks version 14.4.0. So everything is working correctly. In order to know exactly how FFmpeg and socks are working, you have to see their manual pages and also the online reference. Those documents are extremely helpful. You should really look them up. Socks and FFmpeg are essentially your standard Linux programs, basically. They are command line based. They are kind of difficult to grasp, but when you do grasp the concept, it shows that it has very, very much power. You can do a lot of things with socks, a lot of things with FFmpeg, a lot of things with Pulse Audio too. You just have to make sure to read the manual and understand how things work. And that might take a while, but once you do, it really, really pays off. So I'm going to give a few examples here. Yeah, so now that we have the required software, we have to set up the actual method of recording. Like I mentioned, it's all done through the command line. I have set up a recording directory here, right here. And in here you can see a few different files. The SH files are shell scripts. If you're familiar with the things in Windows, it would be something similar to batch files. They have a set of commands in them that I have written beforehand, and if I execute it, it executes those commands in order, so I don't have to write the thing manually all over again every time I want to record. That's very, very useful. Right, so about the scripts. The most important script from these ones is, of course, the recording script. This one, record.sh. In it we have, let me resize the thing to correct size. There we go. Yes, this is kind of complex, but I will go step by step to explain what is actually happening here. Also, I need to have this thing ready. So, first of all, this is a header that says, hey, this is a shell script file. You can also write bash here. If it's just some commands, it doesn't matter. Some things require you to write bash and not shell, because it's more sophisticated like that. Although I think in modern Linux it doesn't really matter a whole lot, because shell is a link to bash anyway. So, first of all, we have ffmpeg. This is the full path to ffmpeg. It's not strictly necessary to write the full path. I just did it for convenience sake. If I ever install ffmpeg somewhere else, you can just write ffmpeg for all that it matters. Xerror just gives you some additional information about any errors that you might find during the recording. Again, not strictly necessary, but it's good to have in order to see what goes wrong. Now then, -f means format, and pulse means pulse audio. So that means that we are starting... oh, that was strange. We are starting this place here, the way for ffmpeg to grab the audio from pulse audio, and here, if you look at this, it says -i, which is input, ALSA output, which means that ffmpeg is asking pulse audio to give it the stream that comes from ALSA, the ALSA output. That means that ALSA output means that the arrow that points out from the software to the hardware is this one. So it will be the green stream, which is the game audio stream. Then, what it says here is .pci something something analog stereo. This is the unique identifier of the sound card. You can get that identifier by executing certain pulse audio commands, something like pulse audio minus dump syncs and something like that. I don't remember exactly, but you can quite easily find that on the pulse audio documentation. So anyway, the last part here is .monitor. That means that ffmpeg is asking pulse audio to take the output as if it was an input. So route it to the other side, to ffmpeg. Normally, if you were not recording, the sound would just go to ALSA and would go to the headphones. That is normal behavior. And it would not go back to pulse audio and to ffmpeg unless you loop the thing around. So that's why you need to add the .monitor that tells pulse audio to actually do that. Now, next we have another F, and use another device, another input, again pulse audio, with the input being ALSA input this time, which means that we are talking about this input here. This time we again need to define the card that we're talking about. This time we don't need the .monitor part because it's already an input and we don't need to route it anywhere. Under normal circumstances, and if you're not recording anything, that means that things from the microphone go to the sound card, go to ALSA, go to pulse audio, and pulse audio drops it all because it's not being used by anything. Until, of course, something goes and asks it to use it, and it routes there. So that's exactly what is going on when you start the recording. So that's that for the first two inputs. Now we have another input here with the format X11 grab, and that's the video input here. again, go back to the graph, and here you can see that FFmpeg this time needs to grab its input from the X server, and that is exactly where X11 grab comes from. That is a special virtual device that connects to the X server and asks it to, once again, like Pulse Audio did, to route the output that normally would go to the hardware to FFmpeg. Then there are some special parameters here. We have -R, which stands for frame rate, and we have entered 30 here because the maximum frame rate that YouTube accepts is 30, anything else is discarded. Then we have S, which means size. We have set to 640 on 480 here because this is the file that I'm using to record Might and Magic 2 Gates to Another World, and that's exactly the size of its window. Then I, the input device, like here we had the name of the sound card basically. Here instead we have the name of the X server. The interesting thing about the X server on Linux is that, unlike on Windows where there's just one graphical server that handles everything, on Linux you can have several X servers running on a single machine or several running on several machines. So normally you still choose 0.0, which means X server 0 on display 0, and that's that, although you could also technically record the screen from, say, another computer over the local area network. So again, that shows the flexibility of FFmpeg. Then, after the plus, it gives an offset. So that would mean that we are trying to record an area of 640 by 480, but we are starting from the coordinates of 3 pixels and 23 pixels. That means that we're not trying to record the window decorations, because, well, during a game you don't want those to be visible. Right, so that sums up the whole input part of the FFmpeg command. Now we're going to the output part. The only thing that is really necessary in the output part is to have an output file name. However, in this case, we still need some additional things to say. First of all, the map parameter. It tells it which input stream to use for a given output. So, for example, if I want to record, to define the parameters for the first stream, I say map0, and it automatically takes this stream and outputs it to this output. Then we define the audio codec that we want FFmpeg to encode our stream in. In this case, this is PCM S16LE. That means it's simple wave audio, pretty much raw audio. Then we say that we want this to be multi-threaded. Set the threads to 0, which means automatic. It automatically detects how many cores you have and sets the threads appropriately. Then VN means don't record video for this output. And then we have the output file name. Same thing for the second output file that we want to define. The first output file was the game audio file, this one. The second one is the microphone audio file, that one. The parameters are exactly the same, you have to repeat them, and just the file name is different. Then the last thing is the last stream, which is the video stream here. that has to output the video only file. We say that we want the codec to be libx264, or libx264, not sure how that should be said. This is a library that encodes things into the H.264 format, which is a very good format, multi-purpose, very useful, very modern, and that's definitely something that you can use to record things. Then we give the quality of the video to be set to 3. 3 means that it's nearly lossless. It's not exactly lossless, but it's nearly that, to the point where the eye can usually not discern between the original and the thing encoded like that, but it gives you additional performance. Then this is motion compensation. I have set this to 0.9, which means that it is tuned towards static images, because Geats of Another World is definitely not a game with a lot of movement. However, if I was to record something with a lot of movement, say Unreal, I would have to set this to something lower than 0.5, say 0.2. to say that I want you to optimize for quick movement. Then again, set it to multi-threaded, set audio to not be recorded, and output the video file. .mkv implies that the audio file must be saved in the Matryoshka container, and that's again a multi-purpose container that it doesn't have many restrictions at all, and everything that you save in it will be saved as is. It also can contain whatever you want, basically. These are just comments, don't bother much with that. It's just something I tested previously, like recording directly from ALSA, going right around Pulse Audio, but, well, it doesn't work all that well with ALSA. When Pulse Audio is running too. Yeah, anyway, so that's that about the recording script that I have set up here. Now there are some additional scripts in this directory. The Paper Doll script, for example, is pretty much the same script, just without recording the game audio file, because, well, there's no game audio. Then, what else? The move script here is made so that I could use this as a form of a stopping button, well, the pause button, because you can stop the recording, but you can't pause when you're using FFmpeg. However, you can stop the recording, then rename all of the files and start recording again, and then put those files back into one after you're done with all the recordings. So the move script automatically renames the files that it's pointed to have the current timestamp, therefore you won't get things overwritten. The clean file removes all the recordings from this directory while leaving alone all the scripts and whatnot. The mux file is quite important. I have written a special example mux file here, and I will show you it right now. So basically, this script file is what I have to run after I have everything recorded. What it does is it invokes SOX to combine the audio files, and then it invokes FFmpeg to combine the audio and video files. So this is what we have here. Again, the header that defines that this is a shell script. And first of all, we have SOX. This is the invocation of no clobbering, which means that it will not overwrite the files if the files are actually existing already. That is useful because if you accidentally run the script, even though you didn't want to, say you want to press record, but you accidentally pressed to mux everything, well, you would then lose your recording, which would be very bad, or vice versa. So this is a failsafe that makes sure that this does not happen. That's why you have the clean script if you do want to remove everything and record anew. Then v3 is something that makes SOX more talkative. By default it doesn't output a whole lot, but setting it to v3 makes it tell what kind of file it is processing here. So it processes the file with special things to filter the noise here, noise reduction. You also have to give the noise profile that you generate by giving SOX a special sound file that contains pretty much only the noise without anything else. Then SOX analyzes the noise, pretty much remembers what it was, and it generates you a profile file, which can then be used with the noise red filter to filter out the noise. Then 0.1 is the amount of filtering applied. By default it's something like 0.5, which is crazy. That means that it would filter way more than you actually need to. By trial and error, I've found that in my particular case, I need something like 0.1 in order to filter out the noise completely, but also not make it drown my voice. So that's something that works for me, but it may not work for everyone else, because, again, it depends on the environment you're in during recording. Also recording equipment. Then we have the gain filter. What it does is it normalizes and equalizes the volume so that it's not too loud or too silent. And M tells it that I want to normalize the audio, also to make both the left and right channels to be pretty much the same, because I'm using a stereo microphone. Then the next line here is another SOX invocation. What it does is it mixes the newly created file, normal.wave, with the other recorded file. It should be audio A actually, it doesn't matter. Everything else is pretty much the same, just that we have -m, which says that you have to mix things. We have 2 inputs and 1 output, and we also don't have any form of extra filters, because we don't need those right now in this command here. Then next is FFmpeg. Once again, we have been here. Now we need to do this, to combine an audio file with a video file into one video file. So that's exactly what we're doing here. With FFmpeg, you're using as input a video file, then as another input the audio file. Then you give the video codec here. In my case, I have given it libvpx, which is the codec that you need to use in order to create a WebM file. And the WebM standard is something that YouTube likes very much. It's also a very, very good standard anyway, because it has very strong compression. So it's very good to use that for sending videos over the internet. Then this here says that the encoding quality must be set to good. There is also a setting best, but again, you don't want to use that, because the good quality is already undistinguishable from pretty much lossless encoding from, well, for people who are not very sensitive to things like that. So usually quality good is enough, and it gives you okay performance. Although this codec, due to the fact that it compresses very, very well, it really does it very slowly, at least right now. It's possible that it will get better in the future. It already moved from 3 frames per second to 5 frames per second, and probably it will get even better as time goes, but, well, we'll have to wait and see. Then this thing here, CPU used 0, says how the CPU should be used, and that means that the codec should try and take its time instead of cutting corners, so that it would get better quality output with better compression instead of trying to rush things. Then this minus V means bitrate, V means video, so it's the video bitrate of 1000 kilobytes per second. Again, you need to experiment a bit with this. Setting this to a low value will give you poor quality. Setting this to a high value will use too many resources and give you a large file. Then the buffer size here, generally it should just be set to double the bitrate. Then again, threads. This time is set to 4 because I think that the libvpx encoder at least could not understand how many threads it's supposed to be making. Normally we would put thread 0 to auto-detect, but I think this was not working back then. Maybe they have fixed that already, I'm not too certain. But yeah, anyway, it's 4 because I have a quad-core PC, of course. The next one is VF, which means video filter. And the filter is the scaling filter, which has 2 options, -1 and 720. What the whole thing does is it resizes the video to be compliant with 720p. It doesn't matter what size it was previously, because -1 means automatically detect the X component and match it to the Y component in order to not stretch the thing. So it automatically generates 720p content, and not something like 600p, which YouTube does not understand and thus downscales to 480. So you get better quality. Then we go to define what codec we want to encode the audio in. So again, codec A or A codec, those two are interchangeable. The codec A is kind of newer and probably better to use in this case. I have given Vorbis here because I want this to be encoded in Ogg Vorbis. Again, it works very well with online videos. Its compression is pretty decent and the quality is good. This thing, strict -2, it is not very necessary, and I think it's not needed currently for FFmpeg, just because I used the previous version of FFmpeg, in which the Vorbis encoder was considered to be experimental, and it doesn't enable that unless you actually specify that, yes, I know what I'm doing, let me record in Ogg Vorbis format. There's another encoder called libvorbis that was not experimental, but on the other hand it had poor compression, I think, or poor quality, I don't remember which, or perhaps a compression to quality ratio. Yeah, basically Vorbis is better to use than libvorbis, at least in the current version of FFmpeg. And of course, lastly, we have the output file. The extension is WebM to make sure that everything conforms to the WebM standard. Again, YouTube really likes that, because it shows the HTML5 videos in WebM format, so it doesn't really need to encode that much when you send this type of video to it. So it can put the thing into action a lot faster than normal, and since it doesn't need to re-encode, it saves your very good quality unchanged. So that's all that we have for the muxing part. This one, like I said, it just combines two and gives you a video file that is optimized for viewing on the internet. Aren't there anything else? No, I don't think there's anything else. That's the noise profile file that Songs generates for me. You only have to generate it once and perhaps refresh every now and then if the noise is different from the place that you're recording, but normally just record once and everything else goes as planned. Alright, what else do I want to say now? Well, yes, so basically this is what I used to record Heroes Chronicles recently. Things like Revolt of the Beastmasters. So, yeah, there is slightly different things that I do for Might and Magic 2 Gates to Another World. That is because there is another step that I need to take in order to record My Magic 2 Gates to Another World, and that is to add my custom music to it, because it doesn't have music. And of course you cannot do that automatically by using a script, because you need to choose the music that is appropriate to the current setting in the game, and so I need to use an actual video editing software here. Luckily, there is a very good video editing software here on KDE, and it's called Kdenlive. This is a really good video editor. In fact, it is much better than the likes of Windows Movie Maker, and in fact, at least I find it better than some of the proprietary solutions like Camtasia Studio. Because, well, at least I find it a lot more intuitive, and some of the things that it has, like selecting the region that you want to change without depending on your cursor, that shows you where whatever you are seeing in the video itself. Very useful. There are lots of effects that you can choose from. You can even create your own effects. You can create your own transitions. There are lots and lots of transitions included inside. It also integrates, for example, with audio, and integrates with SOX if you have that installed. It integrates with LADSPA for additional effects, and so on and so forth. It's really good. Also, it's only available on GNU Linux, and well, that's another practical reason to switch to it. Hint hint, nudge nudge. But yes, it is just absolutely wonderful software. I would never go to pretty much anything else, because this is everything that you would ever need from, well, at least that I need from a video editing software. There are also more things that makes Kdenlive great, but I won't talk about that. You can look that up on yourself. on your own, and that's it. So pretty much I import things into KDE Live here, I put them into the timeline, edit however I want, add more audio to it, make sure that the audio is correctly maintained so that you can hear what I'm saying and also hear the music playing in the background, and then I render the thing into whatever format that I want to render it in. So that's that. So let's put everything into perspective now. After setting things up like that, in order to record the video, what I have to do is, first of all, open a new terminal window. So I launch console, like that. Then I go to the directory that I need, that I have all those recording scripts set up. So change the directory to do, re, and do. Quite musical, isn't it? Then from here, all I need to do to start the recording is to launch the recording script. So launch that, and what I see is what you can see on this terminal window here. It records with FFmpeg, everything. And then, after the recording is complete, once I'm done, I press the Q key to stop the recording. Then I run the other script, mux, in order to process the video. Of course, that is given that this is a recording of Heroes Chronicles or so, where I don't need to manually change anything. Then I wait a bit until it's done processing, and after it's done, I already have a video file of the right size, of good compression, good quality, without any noise in the audio, and ready for upload to YouTube. It's really as simple as that. Only 2 shell scripts that I need to launch, and it does everything for me automatically. Of course, it takes a while to set up properly, but once it's set up, it's extremely easy to record anything. So that answers the question about how I'm recording everything here. And that means this concludes the information video. In the future, I will also make a tutorial about how to use FFmpeg on Windows, and also other recording solutions there, for those who are either too afraid to use Linux, which you should not be, or if you have some special software that either doesn't run over Wine or it doesn't have good enough performance. So that is still useful in those cases. Either way, I will see you all then. So, until next time, later.